的教授。那这个都是常春藤的学校的名校的，那我就请他来跟各位分享一下，他在传表教书的方式，教书的情况。所以他今天要来跟各位介绍，只是介绍一些他的研究的一些事情，而且只是一个介绍，因为只有大概40分钟左右做一些介绍，会很简单，所以用黑板式的，因为他是比较传统的他比我年纪大一点，这个更传统的那当然是用英文讲的那让你们也了解一下，你假如有机会到美国去，那么到宁夏去上课，大概是什么样子？这个是给各位一点概念的那所以我们今天会先请这个 Professor Richard Norman 先讲 Columbia 来的，他会讲有关这个 learning control， 就是学习的控制介绍一下什么叫学习控制这样子。在下一个钟头我们就请那个 Professor Fan， 他来讲就是那个 input identification， 一个系统有 output， 那我们怎么去 identify 这个 input？input 你不晓得，那他会只会讲应用，他不会讲一些视觉的东西，所以你们要好好听我们也会有录影。Okay, so let me introduce you Professor Richard Norman. He received his BS degree from UC San Diego. No?
Riverside.
Riverside. Okay.
And it was a BA.
BA, okay. The BA.
In physics.
Yeah, 他的那个学士学位是 physics 物理。Master degree is math, right?
And aerospace too.
Okay. Master degree 是 math， 就是数学跟 aerospace。那 PhD what is the PhD? Math? Aerospace. Aerospace. I'm confused anyway. It's everything. So, 那毕业以后 after graduate, you stay 1 year in Bel Air, and then you went to Columbia, right? Until now. So it's in Columbia for 41 years old. 41 years. Right? Last year is 42. 在哥伦比亚大学已经42年 ，42 years. 教书非常经验。Okay, so you want to use blackboard or whiteboard?
Well, I can use both, I guess.
The blackboard,
when I fill up
the chocolate is only that
that size.
That size. Yeah, whiteboard, the whiteboard, we have, I don't know if this works. It works, okay? All right, that's yours. I don't see talk.
Okay.
你要找他。
So I'll talk about the field of iterative learning control, which is motivated by robotics originally, for systems that are trying to do the same thing over and over again, like on a robot on a manufacturing operation, supposed to do the same thing many times every day. And first I'll justify the comment that feedback control systems don't do what you ask them to do, and therefore there's a problem. And then we'll figure out how to fix that problem when you're doing things repeatedly. If you look at the error the previous time you try to do that command and make some adjustments aiming to get to zero tracking error. So first we need to, I want to comment about what feedback control systems do. Not all of you have a background in feedback control, so I'll do a simple example to have something to talk about. Suppose I have a mass and a spring and some viscous friction, and I apply a force to it, and the well, let me use, that's okay. So, given this this differential equation, I could write the second derivative plus some constant b times the first derivative plus some spring constant times x is equal to the force F. And then what does feedback control do? It tries to decide how much, well, let's make a feedback control problem where we want to put in a command to move the mass to some position. So we decide a common thing to do is to use a so-called proportional control and say, well, let me make a figure. We use a constant k called the proportional control constant times some x that you want minus the x that you measure. And so I can stick this up in here, and then I create a feedback control system. So when I'm done, I have a differential equation. Okay, so that's a differential equation that says if I put in a command to move to a specific x star, what will happen is the solution to this differential equation. And in this case, if I ask for x star to be some constant, then you expect a constant particular solution, which means the second derivative is 0, first derivative is 0. So after everything stops moving, we have the spring constant plus the constant of our control law times the constant particular solution is the constant times the desired solution, or in other words, we ask the control system to move the mass to a position x star, and what it ended up doing was something a little less than you asked. So we asked for x star, we got k over little k plus big K times x star, and that's not what we asked for. That's typical. Feedback, this is a proportional controller, and constant commands to proportional control systems essentially always have a constant error when they get done responding. Yeah, so that's one example. We can let's do a simpler one where we just, let's see if this is, suppose I try a first order differential equation, and again use a proportional controller. Then I can, so I'm just trying to be simpler than having a second order differential equation. So I could write this as dy dt equals minus ay well, no, minus A I take this y to the other side, and I get, well, minus A plus k y plus k times y star. So that's an example of a state variable, simple example of a state variable. I can think of it as a state variable equation. It's a first order equation. So think of it as x dot equal ax plus du, and y is cx. So here's my a, and here's my b, and then what's the solution to that equation? And the c is equal to 1, huh? So then the solution says y of t is e to the minus a plus k y of 0 plus an integral 0 to the present time e to the minus a plus k t minus tau y star of tau d tau. Okay, so that's solution to a state variable equation specialized to this problem.
You're missing a t. E of potential mass.
Yeah, I sure am. Okay, so now, so I want to do some interpretation. So this is a typical feedback control system, uses proportional control. Y star is what we wanted the system to do. That's the command we gave the control system. What it actually does is this. Suppose we assume 0 initial conditions, then what the feedback control system does is not y star at time t, it's this integral of the command. And it's an integral over everything you've ever asked for, all previous commands. And if you think about this, this is like a weight factor. So when t is equal to tau, then this looks like 1. And that says the most recent command at time t has weight 1. But the integral goes all the way back to time 0 and has smaller weights going back in time. So this is a weighted average of the command. It's not equal to the command. And so a feedback control system will do a good job of performing the command. If you ask the command to move around, if it doesn't move around very much, we can define a time constant for how long it takes going backwards in time for this exponential to get small. And so whatever that amount of time is, you shouldn't change the command much in that amount of time, or your feedback control system will not be able to do a good job of performing the command. But the point I want to make is that